Everyone, my name is David, and welcome to the Intro to Python workshop for TritonHacks. Before I get started, if you guys would like to follow along with the slides, I left a link here. Feel free to type this in yourself, or we're going to leave this in the description of the video as well. Cool. So, what is Python and what is it used for? Well, Python is an interpreted general purpose high level programming language. I know it's a lot of words at once. All you really have to know is that Python is a programming language. It's definitely on the easier end of programming languages that you'll learn, and it has a wide variety of uses. So some of those uses include machine learning, software development, data science, game development, web development, robotics, and like a ton of other stuff. So Python is really versatile. I'd say most programmers use Python in some way, shape, or form because it's just such a good language to use, and it's also really easy to learn. So there's been a lot of libraries developed for Python, and what a library is essentially like a little snippet of code that you can, I guess, use to improve on your own code. So what this means is that like these libraries will help you write cool things. Like for example, Pygame, that's a game development library. Pandas is a library for data science, and NumPy is also used for data science as well. So these are all cool libraries that have been developed for Python. They let you do a bunch of really cool things. And Python's especially popular because a lot of these programming languages don't have tools that can do the same things. That's why Python's really popular for data science, especially, as well as like game development, for example, with Pygame, because these libraries are just so powerful. Also, Python has a really good amount of flexibility. So compared to other programming languages, Python is really simple. You don't have to do stuff like declare types if you've worked with Java before. It's very simple. We'll go on to that in a few slides. So let's start with something straightforward and simple, and let's write a hello world program. So if you want to print the words hello world to the console, all you really have to do is type one line, just print and then parentheses in quotes hello world. And so I can show this really quick. If I open up Python myself, so this is the Python interpreter. If you install Python, all you have to do is really search for it, and this little window will come up. And if I type print hello world, it'll just print hello world. So really simple to get that started. Other programming languages are a bit more complicated usually, but with Python, all you need is a simple print statement. You don't need any like main method, no imports. It's all very straightforward. And here we have a little meme, I guess. So this is hello world in Python. This is hello world in assembly. It looks like you don't have to know this. It's complicated, but yeah, Python is pretty well loved because of how simple things can be. All right, so moving on, I'd like to talk about variables in Python. And so variables, as it says here, are locations in memory used to store data. And so what that means is that you can store information such as like this, these two words, John Smith, in a variable to be able to reuse it again. So in this case, full name is equal to John Smith. This is a variable full name, which stores a string called John Smith. If you're unfamiliar with, I guess, programming jargon, a string is just basically just characters combined together. In other words, just like words or sentences, stuff like that. That is what a string is. And then we have another variable below that called age, and we see age is equal to 23. And what we're doing is we're storing the number 23 in the variable age. And 23 in this case is an int or an integer. So if you've taken math classes before, you're probably familiar with what an integer is. It's the same thing. We just abbreviate it as an int. And so in this case, like I said before, the reason why we store stuff in variables is so we can use that data again in some way, shape, or form. And so, for example, if I wanted to print out 23, the age that we stored in age, all we have to do is type print age. So really simple. And then 23 would be printed to the console. All right. Next up, I'm going to cover assignment operators. And so assignment operators are just different ways that you can, I guess, insert or change a variable. And so before I showed you the equal sign, so you can assign a number or a string to a variable, for example. You can also do some other things. So there's plus equals, there's minus equals, there's times equals, there's divides equals. We don't cover that here. Don't worry about that too much, but knowing plus equals and minus equals are two pretty good ones to know. And so it's pretty straightforward, I think. If you want to add, for example, 1 to age, so our age before was 23, and if we do age plus equals 1, what it'll do is it'll add 1 to the variable age. And I could just demo that really quick because it's pretty easy to do. So let's go back and we'll create a variable age and we'll set it equal to 23. And now if we want to print the age, you can see age is 23. And if we want to add 1 to the age, age plus equals 1, nothing prints out. But now if we print out the age one more time, we can see that age went up by 1. And we can also do age minus equals 1. And now we'll be back to what we were at before, at age is equal to 23. So assignment operators are pretty straightforward. Yeah. So next up, I'm going to cover comparison operators. There's a whole bunch of these comparison operators that you should know. These are a bit more complicated. And what they do is they're used for comparing two values. So say, for example, we want to see if like two values are equal to one another. So let's say we have like our age, which we know has 23 in it. We want to see, okay, is it equal to 23? We could type age equals 23. There's actually some better examples down below. So as you can see, is 9 equal to 10? We do two equals for that. In this case, 9 is not equal to 10, and we know that this will return a false statement. So there's two types of Boolean values in Python you should know. There's true and false. Well, there's only really two Boolean values in any programming language, but basically you should know that when something's not equal to something else, or when a comparison operator fails, I suppose, that returns false. And otherwise it'll return true. So in this case, is 6 less than 21? Obviously 6 is less than 21, so this will return true. Is 3 greater than or equal to 3? That is a true statement, so it'll return true. And so there's a whole bunch of these you should know. We demoed a few of them here, but there's the double equals, which indicates two things are equal to one another. There's the exclamation point equals, which indicates will return true if two things are not equal to each other. So for example, if we did 9 and then exclamation point equals 10, well, we know that 9 is not equal to 10. And so we know that 9 is not equal to 10, which is a true statement. I know it's a little confusing to grasp at first, but it's basically just the opposite of equality. So if this is like 10 equals 10 or 10 exclamation point equals 10, that would actually return false because 10 is equal to 10. So just like reverse logic, I suppose. And then we have greater than, or sorry, less than, greater than, and also less than equals to, or sorry, greater than equals to, and then less than equals to. Getting my operators mixed up. But these are pretty straightforward, and I'll also demo this again really quick. Ooh, that's all I wanted to open. So let's say we have like another variable. Let's call this age 2, and we'll set this equal to 24. All right, so is age equal to age 2? It is not. So we know that age, the original age stores 23, and this new age stores 24. And so if we wanted to, for example, make age equal to, or sorry, the new age equal to the original age, we can just subtract 1. And now we see, okay, is age equal to age 2 now? It is. It's true. And so you can do this with a whole bunch of comparison operators, but I just want to show the simple example here. We'll go into why these are important in a few slides. I'd also like to quickly cover logical operators. And so these are important when you're comparing Boolean values specifically. So for example, we'll start off with and. So this returns true if both statements are true. And so for example, as we showed before, let's say we have x is less than 5 and x is less than 10. I'd also like to quickly go over logical operators as well. Logical operators are important when you're comparing Boolean values specifically. And so there's 3 logical operators that are important to know. There's and, there's or, and there's not. So to quickly go over what and is, this returns true if both statements are true. And so just to show an example, let's say we have the variable x and it's storing the value 4 inside of it. And now we have 2 statements here. We have is x or sorry, we have x less than 5 and x less than 10. Well, we know that x is equal to 4, so is 4 less than 5? That's true. And is 4 less than 10? That's also true. And so what we're doing is we're saying, okay, we have true and true. And because both of these statements are true, these two statements here, true and true, then this whole entire thing is going to be true. And then let's move on to the or statement. And so this returns true if one of the statements is true. So for example, we already know that x is less than 5, so x is 4. So this right here is going to evaluate true. But now we have to look at, is x less than 4? Well, x is equal to 4, so we know x is not less than 4, and this is going to be false. And now if we want to look at the statement as a whole, we're saying, okay, true or false. In this case, remember that or returns true if one of the statements is true. And because this statement here is true, this entire thing will evaluate to true. And lastly, there's not. And so what not does is it reverses the result and returns false if the result is true. And so to show another example, this is what we had at the beginning. And we know that this is a true statement. But because we have not in front of it, what this does is it will negate true and it will make it false. So it just negates whatever is inside of those parameters. You also don't even need to put these parameters if you want. So for example, if like you wanted to type not true, this whole statement would just evaluate to false. Cool. So here's a little bit of a pop quiz. If you're watching this over video, I suggest you just pause this video really quick. And on the next slide, we'll go over the answers. So pause here. All right, so let's go over the examples to the pop quiz. So the first one, we have a variable x set equal to 3, and we're subtracting 2 from x. And now if we print x, well, we have 3, we took away 2, and so our answer is going to be 1. 1 will be printed at the console. In the next case, we have a floating point number 9.0. We didn't talk about this before, but floats are just numbers with decimal places after them. So 9.0 is a floating point number. And if we divide 9.0 by 2, we know that 9 divided by 2 is 4.5. And so now we're storing 4.5 in y, which originally stored 9. And now if we print y, what we'll get on the console is 4.5. And then one last example, which is a little more complicated. We have this statement right here. The first thing I usually like to look at when I'm looking at Boolean comparison operations is I kind of follow the order of operations. So my eyes first go to inside the parentheses. And in this case, I look from left to right. So is 3 less than 2? 3 is not less than 2, so we know that this is false. And we're comparing false with true with an AND operator. And so false and true is going to be equal to false. But then we also have this inside of this not operator. And so by doing not false, what we're doing is we're storing true inside of Z. And so when you print out Z, it's going to print out true. Okay. So moving on to input and output, it's important that you understand how to read text from the console or from the terminal. So I already covered the print operator a little bit. Print can print out any data type that's built into Python. So strings, integers, booleans, you can print all of those out using the print statement. If you want to read the user's input, what you have to do is just type input in parentheses and then the text that you'd want to be displayed to the user right inside of those parentheses. And I'll show a little demo of that in just a second. You don't have to put an argument here, but I'll show you what it will look like when you do use an argument. And so it takes in external values, so it doesn't have to use any arguments in the script. So what this means is that this is all given by the user. So if you're the one running this program, you're the one that fills in this input. The value returned from input is always a string. So when you type in text, it is automatically converted into a string. And yeah, let's show what this looks like through a quick demo. So let's say we just want to read the input from a user and let's store it in a variable. Well, I'm just going to call this variable text, and I want it to store the inputs of a user. And so, like I said before, you don't have to do any parameters if you don't want to. So let's just see what happens if you don't. We go to a new line and there's nothing there. So we're like, okay, let's just type in some text. All right. Go to the next line. It's like Python's like, okay, well, that's done. But now we know that if we print out text, now we know that the words some text are stored inside of it. And so I'll show another example of what happens if you use a parameter. So let's say like, what's your name as like a question. And so you can see it asks you what's your name. I'm just going to say David because that's my name. And if we print out text2, prints out my name. And so that is how you use the input method. Cool. So here's some more examples of how you can use input. This is also like a bit of a fancier print statement. So when you're using print, you can also just put a variable name directly in it and then add it to a string. So for example, let's say for this case, this name stores the input of Maggie, and we want to print out Maggie. Do you like to code? And so we just put in the name, we do a plus, and then we have a new string appended to that original name, and it'll print out the name plus this text that we added in. So in this case, this is just an example that shows what you can do instead of putting a parameter to input. So this is equivalent to using the input, except this will automatically bring you to a new line. So if instead we did this before, I'll show this the demo actually. Print, enter y or n. So it prints it, and then like if we do an input, it's on a new line. So if instead you don't want it to be on the same line like we had before, you can do a print statement and then you can collect an input after. And then we have an if statement here. So we'll talk about this in a few slides, but in this case, if the response that we collected, so this is a yes or no question, if the user put in y, we'll print out this line, I like to code too. Otherwise, this else statement executes, but coding is fun. So don't worry about this if you don't understand it so far. We'll cover this in just a couple slides. All right, so next up, I'm going to talk about library functions. And so library functions are functions that are imported into your code from other libraries. And so what that means is that other people have written code for you and you're able to use that code to do cool things inside of your own code. So first I'll talk about the Python standard library. And so the Python standard library basically lets you use a bunch of methods that are already built into Python. So for example, like if you want to find a method to sort a list or get a random number, these are all built into the Python standard library. You can click this link and this has all of the information of stuff that's built into Python. So as I was saying before, say we want to generate a random number, we could search for random and you can see, okay, this library can be used to generate pseudo-random numbers. And the reason why they say pseudo-random is because computers can't generate completely random numbers because that's just how computers are. I'm not going to go into that, but would be interesting to look up if you're interested. And so say, for example, we want to generate a number between like 0 and 5, for example. We can use the random functions randRange method. And so I'll show that really quick here. That was from a failed recording. But the first thing we have to do if you want to use a function from a library, in this case, if we want to use random from the standard library, we have to import it. And so what you can do is you can just type import random. And what this does is it tells your code, okay, I want to be able to use methods from this random library. And now we can demonstrate random.randRange. And there's two different versions of this. There's one with a start and a stop, or you can just specify the stop, which automatically starts at 0. So if you want to generate a random number between 0 and 5, we can do this, and it shows 4. And we can do this a bunch of times. and we'll just keep getting random numbers. This input is also exclusive, so what that means is that you'll never generate the number 5, but you'll generate all the numbers between 0 and 5 exclusive. So 0 through 4, essentially. And so as you saw before, this is what happens when you don't import a library. So if we didn't import random, we'll get an error saying random's not defined. Basically what that means is Python doesn't know what you're trying to do. It doesn't know what library you're trying to access. And so that's why you need to import it so Python knows, okay, random dot something means that we're looking at the random library specifically. Yeah, so random is just an example library. There's a whole bunch of them you can import. But you can only default import stuff from the Python standard library. And so if you want to use something like Pygame, for example, or NumPy, you have to do a pip install. And so I'm not going to cover that in this video, but it's important that you understand how to install external libraries. You do have to use the command prompt a little bit more, but it is important to understand how to do that. Okay, so yeah, as I showed before, this is the general format for importing library function, and then this is how you'd call it. So for example, library name dot function name. So in this case, random was our library, rand range is our function, and then we have our parameters. And then we can also see, okay, this generates a random integer between 0 and 5. And yeah, so that's a quick overview on how library functions work. Cool. So let's jump into coding something. All right. So let's jump into the program that we're going to create. And so what we're going to do is we're going to make a program that generates a random number, and you, the user, are going to guess whatever that number is until you get it correct or until you run out of chances. So this is a very simple program. The first part we're going to do right now, and the second part we'll go into after we go through a few more examples. So starting from the top, first thing we have to do is import the random library. And so the random library, as we showed before, will be used for generating random numbers. And doing an import, all I have to do is just replace these 3 dots with random. So now this will give us access to all of the random methods. The next thing we want to do is let the user have 8 chances to guess what our randomly generated number is. And so chances is just going to store how many chances we have. In this case, we have 8 chances. And we want to also define an upper bound for how many numbers we want to generate. So if you had 100, it'd probably be pretty hard to guess what the right number is. So let's say like 25. I think with 8 chances, it should be reasonable to guess what the proper number is, but we'll see about that. All right. So the next thing we want to do is you want to use rand range, which I demonstrated before, to generate a random number between 0 and the upper bound. And so rand range, one of the options you can do is have 2 parameters. You could have a start and a stop. And so we want to start at 0 and end at our upper bound. And so as I showed before, we actually don't even need to specify the 0. We can actually just type in upper bound. And what this will do is it'll generate a random number in between 0 and 25. Cool. So now we want to print the sentence, make a guess about the number. In this case, we just have a print statement, and we can just type in make a guess about the number. And then again, this is another example of a print statement, but instead we're going to do appending to the original string. So we want to print the sentence, the number is an integer between 0 and blank, followed by the value of upper bound. And so this plus indicates that we're appending to this original string. We need to do plus upper bound. So pretty easy to do that. Next up, we want to initialize the response to the user's input. So as I showed before, you just get the input by doing this. And so we can also have I guess a query, like what do we want to say to the user. We'd probably want them to, I guess, know that they're inputting random numbers. So let's see, make a guess. Input your number guess here. And so this line will print out, they'll be able to type in their number and it'll be restored in response. And then the last part is to let guest store the integer value of response. And so as I was talking about before, response is going to be a string because all input methods return a string. And we want to cast this to an integer so that we can compare it with other numbers. And so all we got to do is cast this to an int. And now guess will store the numerical version of what we inputted. And so that covers the first part of this program. All right, so let's go into conditional commands. So there's 3 conditional commands that you should know about. There's if statements, else if statements, and then else statements. And so each of these serve a really important purpose. And I'll show that right now. So an if statement will execute if the current statement is satisfied. And so we have an example on the right. We're saying if x is greater than 10, then we'll print x is greater than 10. So pretty straightforward. What this does is it will check what the Boolean evaluation of the statement is before it will either enter the if statement or decide not to enter it. So in this case, let's say x is equal to 11. If 11 is greater than 10, then we'll print out x is greater than 10. Otherwise, if x is equal to 9, well, 9 is not greater than 10, and so it will not enter this if statement. So this print statement will never evaluate. Next up, we have else if statements. And so else if statements are basically statements that are checked after the initial if statement is checked. So it's like if this condition isn't satisfied, but this other condition is, then we'll go into this other print statement, or we'll go into this other statement. So in this case, is 9 greater than 8, which we had in x? Yes, 9 is greater than 8. So we'll print out x is between 8 and 10. So we know the information now. Let's say, for example, x was 7. So if x was 7, then this else if statement would never evaluate because 7 is not greater than 8. But then we'll go to the next else if statement. Is 7 greater than 6? Yeah. So we'll print out the statement x is between 6 and 8. And then if none of these evaluate, so if x was like 5, for example, we'd go to this else case. And so an else case is evaluated if nothing else is satisfied. So if x is not greater than 10, it's not greater than 8, it's not greater than 6, then we know that x is no greater than 6, and we'll enter our else statement. And that covers conditional commands. All right, so next up, I'd like to cover what loops are in Python. So there's 2 types of loops you should know about. There's for loops and there's while loops. And I'll also cover control flows briefly as well. So first up is a for loop. And so a for loop is basically a statement that iterates over items in any sequence in the order they appear in the sequence. And so what this will do is, for example, for index in 1, 2, 3, we'll run the loop from 1 to 3. And it's a bit complicated to, I guess, show this in code because first time I looked at this, I was like, what is going on? But I think it's really good to demonstrate exactly what's going on. So let's write this out. For index in 1, 2, 3. So this is a list of numbers. We didn't cover this here, but this is a list, so it's just a way of storing multiple, I guess, forms of data in one location. And we want to print out each of these numbers, for example. So what we have is we're iterating through each one, and we're going to store each of these numbers in index for each time this loops. And so what this means is that whatever's inside of this for loop will iterate as many number of times as the length of this list. And so, for example, we know that there are 3 elements in this list. There's 1, there's 2, and there's 3. And so this block of code will execute 3 times. So inside of this for loop, let's print out what each number is. So in the first loop, we're doing the index in this list of numbers. So we'll start at 1. And so what it'll do is it'll store 1 inside of index to start with. So index at the first loop is equal to 1. So if we print out index, it will first print out 1. And then with the second iteration, so it starts back at the top, looks at the list again, and it's like, okay, we looked at 1, now we're on the second number. And we'll store 2 inside of index for the second time it loops. And so next we'll print out 2. And then back to the top, we're now at the last number. We'll store 3 inside of index, and then we can print out 3. And so if we run this, it'll print out 1, 2, 3. So that's the basics of a for loop. Another way you can do this is to print out numbers in a range. So I use range quite a few times. So if we do range from like 0 to 3, for example, and print out index, it'll print out all the numbers between 0 and 3 exclusive. So 0, 1, 2. This is really good if you don't want to write out an entire list of numbers and you just want to go through a loop a certain amount of times that you specify. Cool. So next up, it's important you know about while loops. So this keeps executing as long as the current condition remains true. So for example, while 9 plus 10 is equal to 21. Well, this while loop's never going to execute because 9 plus 10 is unfortunately not equal to 21. But let's say, for example, like we have while, let's say we have a variable x, we'll have it equal to 0. And we want to say while x, I'll use parentheses here. Actually, that's fine. While x is less than 5, we'll print out what x is, and then we'll also decrement x. So what I'm doing is first it'll be 0, or sorry, plus equals, yes. First it'll be 0, and then we'll add 1 to x, and then we know x is 1. Okay, is 1 less than 5? Yes, it is. We'll print out 1, go to 2, 2 is less than 5, and then all the way up until we get to when x is equal to 5. And in this case, well, x is not less than, or sorry, 5 is not less than 5, so we would stop the loop right there. And so just demo this really quick. So we start at 0, and we go all the way up to 4, and when x is finally set equal to 5, that's when we'll exit the loop. And we can also print out x, and we can see that because this last line executed before it checked again while x is less than 5, then x is going to be equal to 5. Cool. There's also the break statement and the continue statement. So what break will do is it'll exit a loop prematurely. So let's go back to this example. While x is less than 5, and we can add a conditional in here. Let's say if x is equal to 3, then we just want to end it. We want to break out of the statement, or out of the loop, I mean. Otherwise, we'll just print x, and then we will do the same thing we did before, just add 1 to x. And so if we do this, oh, forgot to reset x to 0. So let's remake this really quick. If x is, I'm just going to retype it out. Break, print x, and then we add 1 to x. Cool. So in this case, we made it all the way up to 2, and then in this case, well, x is equal to 3, so we'll break out of the loop, and we'll just stop it right there. There's also the continue statement, and so instead of breaking out of the loop, we can do continue to just skip over an iteration. So, for example, if we didn't want to print out what 3 is, or didn't want to print out 3, I mean, if x is equal to 3, we can I'll just continue, and we'll print x again, and we can iterate x. And so what this will do is it'll print out 0, 1, 2, skip 3, and then do 4. So let's see this. Forgot one thing as well. So it's not going to execute this x plus equals 1 anymore because I did continue. So one way to fix this is to add that x plus equals 1 inside of this if statement, then continue, and then we can print x and also do the x plus equals 1. And yeah, this would work. I forgot to reset x equal to 0. But in this case, it stops at x equals 3. I ran this loop again, and since it did this iteration, checked is x equal to 3. In this case, it was. We added 1 to x, and then we continued, and then it printed out 4. So hope that made sense. You'll be able to see that a little bit more in detail during the next coding example we do. All right, and I think the last thing we're going to cover is string formatting. And so we showed string formatting before, or I guess what strings look like before. You could just store a string inside of a variable. So we're storing Bob inside of name. But we can also use string formatting to, I guess, store variables in strings is probably the most common usage of string formatting. So if we want to print out hello Bob, instead of doing like hello plus name in this case, so this is poorly written, but if we did hello plus name like we showed in those if statements before, it'll just append the name to the string. But instead of just appending, we can directly insert the name into the string using string formatting. So in this case, try to clear these drawings. We have hello, and then we have %s. And so what %s means, it's just an indicator that you're inserting a string. So for example, if you had %d and like name was instead like, I don't know, x and like x is equal to 5, then it would be like hello, comma 5. But %s indicates that you want to be inserting a string specifically. So in this case, since name stores Bob, and we use this operator to format the string, then it will print out hello Bob. Another way you can do it is just doing dot format. So instead, if like this is too confusing to do the %s, you can actually just do these squiggly brackets and then do dot format and do name. So that's another easy way to do it. And then this is like the cooler way of doing it, I suppose. This is with f strings. It's a new feature in Python 3.7. But instead of actually doing hello %s and then name, you can do hello, and I think this is supposed to be a squiggly bracket and not parentheses, but hello name and then with an f at the beginning. So let's demonstrate that really quick. And so I suggest using f strings. I think it's probably the cleanest way you can do it. So let's make a name and we'll just put in David, and then we'll print out an f string, hello name. And so what it'll do is it'll look up whatever is stored in name and insert it into the string. Yeah. And so I don't think the parentheses works. I think that just prints out, yeah, hello name. So make sure you have those squiggly brackets when you're inserting a variable into a string. Cool. All right, so let's jump back into our coding example from before and finish it up. Okay. Okay, cool. So I'm just gonna select all of this and uncomment it. There we go. All right, so first thing we have here is a while loop. We want to repeat until the guess is equal to the answer. And so we stored our guess in this variable guess, and we want to repeat until the guess is equal to the answer. So while the guess is not equal to our answer, which is stored in answer, we want to keep running this loop. All right, so this while loop will run until we get the proper guess. Next up, we want to decrease the number of remaining guesses by 1. So with every iteration of the loop, we just want to make sure that we're decreasing the number of chances because we've made a guess for this answer. And so we can do this by doing chances -1, or we can also just do chances -=1. Next up, we want to tell the user if they're out of chances, and we'll show the answer. So if they guess too many times and they have 0 chances left, so in this case, 0 chances, then it'll enter this if statement and it'll print out, you didn't get the right answer, this is what the correct answer was. And then finally, it'll break out of this while loop. So it'll stop looping because they never ended up getting the right guess and they ran out of chances. Next up, we want to see if the guess is smaller than the answer, we want to print something telling the user to enter a bigger number. So this is kind of giving them hints, like hot or cold, I guess. If guess is less than the answer, then we'll want to print, we know that guess is less than the answer, so we can say guess a higher number. Otherwise, if guess is greater than the answer, say guess a lower number. All right. And the next up, we want to ask the user to enter a new guess and tell them the number of chances they have left. So As we did before, same thing. You want to ask the user to input their number. And once again, update the guess by casting the response to an integer. Cool. And so with every iteration of the loop, we'll go back to the top. We'll say, okay, is this guess equal to the answer? If it's not, then we keep going in the loop. Otherwise, we will print out whether or not the user guessed the correct answer. So in this case, say, congrats, you guessed correctly. So this is a bit of a more advanced example. This is a if statement inside of a print statement. This is something called a lambda function. And so it's just a fancy way of doing things. You don't really have to know this, but quickly show this right here if you're interested in learning. So if the guess is equal to the answer, so I should have just done that there. If this executes properly, then we'll print this. Otherwise, so we have this else case. Otherwise, we could say, sorry, you didn't get it. So the format is you type the string. If the condition is satisfied, so if guess is equal to the answer, you'll print it. And then you have this else case that will just print out otherwise. And then we'll print out the correct answer. So correct answer is going to be, and let's just use an F string for this. Correct answer is going to be answer. Cool. So let's try running this and see if our code works. The number is an integer between 0 and upper bound. Generally concatenate a string, not an integer to a string. This is on line 18. Right, so we also want to make sure that we cast our number to a string, because you can't append a number to a string easily. You have to cast it to a string before you can add it to a string. So let's try this again. There you go. All right, so we know the number is between 0 and 25. Let's make a guess. I'm going to say the number is 11. All right, 11's too low. Let's say 22. All right, so it's between 11 and 22, 17. All right, wow, that was lucky. Third time's a charm, I guess. So the number was 17. And so our program just ends there. You print out the correct answer, and we congratulate the user. Let's try this again and see what happens if we don't get it. All right, so 0. What? Okay, that's rare. Wow, 0, 0, 0. So if we go 10 times, then it says sorry. Correct answer 7. And yeah. Oh, I guess this prints out twice. If you didn't get the answer, I guess it just prints twice, but I think you get the point. Yeah, so this is the end of our coding example. So just to finish up the workshop, there's a few resources I linked here. If you're interested in learning more about Python, I highly recommend you check out the Python cheat sheet. Sorry, this has a bunch of important methods for Python. So if you ever need to look something up, like for example, if you want to write to a file or open a file, if you need to do like string operations, if you want to work with lists, which you didn't cover in this, you can learn more about that on this little cheat sheet. LearnPython.org is also really good if you're interested in more guided tutorials. This, I guess, workshop is much less hands-on than a lot of these lessons would be. So if you want some more actual coding experience, I highly suggest you check out LearnPython.org. Here's the Python documentation you can check out. And I think this is also another Python learning resource. So if you want to learn more Python, also check that out as well. Otherwise, thank you guys for watching the workshop. I hope you took something away from this. Feel free to leave any feedback in the comments. If you have any questions, you can respond in a comment, and I'll try to get back to you as soon as I can. Otherwise, good luck at TritonHacks. Hope you guys all have a good time, and I'll catch you all later.